to the right page and it'll help. 7C? 7C says use a calculator, or 7 says it doesn't have a C. Oh. You must have went back. You must have went back to another. It wasn't last night's homework, but that's okay. T is between 0.
I do. Yeah, really just been forever was like, which one makes it water?
My apologies. Less than or equal to 2 pi. So you don't need part A or part B. Find the total distance traveled by the particle. So since this is velocity, I want the integral from 0 to 2 pi of e, and this is a calculator problem. So I would first graph it to see if it ever crosses over, right? And see where between 0 and 2 pi. Yeah, because I don't have my calculator. 0 to pi over 2. So she went through, yeah, she found the 0. So which ones are positive and which ones are negative? So what I would do, since I'm doing total distance traveled, is I would do minus plus. That would make it absolute value, because if this one's negative, right? So because the integral can be negative, but total distance traveled is not going to be negative. So I need to make it positive. Does that make sense? Or same thing. Same thing. And you're going to put this on your calculator because this is a calculator problem. So I'm going to put this in y equals, and I'm going to hit calculate. So I can calculate the integral. I'm going to do from 0 to pi over 2 and get that value. Let me get my calculator. So you like this, Dylan? Okay, well, let's look at it. Well, for one, she probably in part A. Yeah. Here's how you can think about it. Now, this is a calculator, but she got exact values. What I'm assuming you did is you said 0 equals e to the sine t times cosine t. Where does that equal 0? Well, it's going to equal 0 where either this is 0 or this is 0, right? E to the whatever is never going to be 0. So I'm only looking where cosine t is 0. So where does cosine t become 0? And that's where she got these values. So I'm going from 0 to 2 pi, pi over 2, 3 pi over 2, and 2 pi, right? Those are all the places where cosine is 0. Now I need to know when is it positive and when is it negative. Well, this is always going to be positive. Do you agree? Okay, because I'm raising e to something, and nothing I can raise to is going to make it negative. So where is cosine t negative? Because a positive times a negative is where I'm going to get a negative. Well, from 0 to 2 pi, or from 0 to pi over 2, it's positive. From it's negative and it's positive. So that's how we know that this area is going to be negative, because it sits below the x-axis. Yes. So now if I were to graph it, so that's why we did absolute value, right? We are at the end of calculus, so there are tons of things to remember for sure. That what, we are at the end of calculus? Kind of dark. Okay, y equals e to the sine t cosine t. I'm going to do a zoom trig on here. No, it gives you a negative 2 pi to 2 pi window. Zoom trig. Funky. But here's what I'm going to do. I'm going to look at the area first from 0 to 2 to pi over 2. So I'm going to go, second, calculate, number 7, from 0 to pi over 2. Okay, so I got 1.718. They probably went through and solved this with a use of, I'm saying if it's a calculator, I'm using my calculator. But you could do this. You could find the integral on this, because you could let u be sine t. That means du is cosine. And so that's what they went through and did, so that they had exact values. Does that make sense? They solved it exactly. They said, okay, I want this from 0 to 2 pi. So what they did each of these evaluated. All right, so if u is sine t, you did all that. But then you have to find that initial value so that you can solve for your constant of variation, right? Because this is going to be, all right, so you got e to the u du, which would be e to the u plus c, but I'm going from 0 to 2 pi, but I know I have to split all this up, right? But what I have to do, yes, this is position. Well, because your initial position, you've got s of 0 equals 3, you're going to need to plug in for that constant, because this is particle motion, so it's a little bit different. So, but you're going to need, if you plug in this way, do you get the right answer? So if you did e to the pi over 2 minus e to the 0 plus the absolute value of e to the, yes. Ugh. Do you get the right answer if you do that? On that middle interval, they did something with subtraction? I would never do anything with subtraction on those.
Like the answer is 2e minus 2.
You have to have it in one equal first.
That's right. Because the answer would be e to the 1 minus e to 0, which is 2.78 minus 1.
They didn't subtract.
In the parentheses.
Well, they took that's already simplified because they did upper bound minus lower bound. So, like, they have e minus 1, right? Is that the subtraction you're asking about? Okay, because what they did was, all right, so if you've got your e to the sine t, right? If you plug in pi over 2, so if I evaluate this from pi over 2 to 0, you do upper bound, so e to the sine pi over 2 minus e to the sine 0. The sine of pi over 2 is what? 1. So that's e to the first minus what's the sine of 0? 0. So e to the 0. So it's e minus 1. That's why they're subtracting because they're doing fundamental theorem. They're doing upper bound minus lower bound.
With the other ones before that, I would just find, I literally added everything.
You did. You added each, okay, you added each integral, right? So you did this integral plus the absolute value of this integral plus this integral. But this is just the first integral. I think you're thinking about this too hard. You're getting confused with the signs. You have to make it absolute value.
Okay. So, what, like when you set it up, you did the.
Let me do it. Let me do it by hand here. All right, we are 0 to pi over 2, right? And actually, let me do it like this. We know that it's e to the sine x from 0 to pi over 2. Agree? Plus the absolute value of e to the sine x. This one is evaluated from pi over 2 to, is it 3 pi over 2? Plus, move my thing, e to the sine x evaluated from 3 pi over 2 to 2 pi. Agree or disagree?
When you do that one, it says invalid.
When you do what?
When you
Okay, we're going to do it by hand and I'm going to show you. Okay, are you okay here? Okay. Just this one. E to the sine pi over 2 minus e to the sine 0. Does that make sense? That's the first integral. Plus, now this one's going to be an absolute value. And I know that because I know that's where it goes negative. They're all technically, you look very pained and you sound very pained right now. Okay, e to the sine 3 pi over 2 minus e to the sine pi over 2. Upper bound minus lower bound, right? Okay, plus e to the sine 2 pi minus e to the sine 3 pi over 2. Does that make sense?
Yes.
But
when I have to show it to you.
okay.
That's the answer right there.
Was not.
You would, Dylan.
You would.
That's
You would. You would.
so like, yeah. Like I'm at. I don't understand why we're subtracting.
Okay.
Even whenever
What was
there
the
is
answer we got on
subtraction,
top?
it converts.
What was that?
It's e minus 1 plus
Yeah, I got that, but what's the
not
answer?
1 minus e.
You subtract your balance, it's always minus. And then
What was it?
after you subtract that, you always subtract your balance. Okay. You can't not subtract your balance. Does that make sense?
Yeah.
What was this that we got?
I don't know why you didn't do it. That's the one. That's like.
Well, if you did it, I'm showing you the exact answer if you didn't have a calculator and you were doing this, okay? Because you could do this without a calculator. And their answer was without a calculator. But if you have a calculator, now if you're on a multiple choice type question, they're going to probably give you your answer exact, but you could still go in if you had a calculator and see which one. You see what I'm saying? All right, sine pi over 2. We'll just finish this quickly. This one. You sure? Is 1 minus the sine of 0 is 0. Plus the sine of 3 pi over. Is the answer. And when in doubt, 1. Sine of 3 pi over 2. Negative 1. Sine of pi over 2. Plus e to the sine of 2 pi. Sine of 3 pi over 2. All right, this is e minus 1 plus, this is absolute value, this is 1 over e minus e, right? Plus 1 minus 1 over e. Okay, so well, the first thing I need to know is 1 over e minus e. Is that going to give me a positive or a negative number? I'm just trying to think through if this is going to give me a positive number or a negative number. It's going to give me negative. Do you agree? I've got a common denominator here. Because I'm just thinking through, if I didn't have a calculator, how would I determine if that's going to be positive or negative? Because if it comes out positive, I can just drop the absolute values, right? But if it comes out negative, I need to do the opposite of it. Do you agree? Say that again. Okay, so we're fixing to change that, and this is why. Okay. Do we agree? And you know, because you graphed this on your calculator, it should come out negative, right? But let's say you didn't realize that graphically, and you looked at this and you go, okay, I need to determine if what's in the absolute value is positive or negative. This is going to be negative. So if it's negative, right? Or y'all follow me? If it's negative, I can change this sign to subtraction. Remember we did that. We said the positive, any positives add together, but any negatives subtract it, because a negative and a negative add it together.
I'm so confused. I'm failing this. Absolute value change to be positive.
Yes. So we have to force it positive. So look at this. If I take this area, this area right here, right now, is 1 over e minus e, right? 1 over e minus e is this area, but it's negative. I need to make it positive. How do I make that positive? So what we did before, and this is where y'all got confused on that quiz. Remember, you looked at my answer key and you said, why did you subtract that? That doesn't make any sense. And then y'all tried to subtract it on your next quiz, even though it wasn't supposed to be subtracted. And I said, well, what I did was negate the sign because I knew this was negative area. So if you subtract negative area, you're adding. It's the same thing. So I'm changing that sign. So I'm doing, let's call this A, B, and C. I'm doing A minus B, which is going to flip it up here, plus C.
Can we use calculators on this?
Well, no, because it's minus.
It's a minus there.
Right, but it creates a plus.
Correct, because that's what I'm going to, so I'm going to have E minus 1 minus 1 over E minus E plus 1 minus 1 over E. The ones are the only thing I see that cancel. I've got 2 E's and I've got 2. You could, but you don't. I mean, it depends on how the answer's written. Okay, so look at it. Let's look at it graphically. No, I want you to understand.
I'm not going to understand.
All right, if you don't understand, plug your ears. Okay, here's my areas. Do you agree that if I do the integral can be negative? So if I just come in and say A plus B plus C, this area is negative. And that's not giving me area. That might give me the integral, but it's not giving me the area. So the problem is occurring with this. Do you agree? So what happens if I said A minus B plus C? If this was already negative, if I subtract a negative, I'm making it positive. That's exactly what you're doing in this problem. And no matter where it comes, what if it was first? What if it was something like this? And this was A, and this was B. If I do A plus B, well, what's going to happen? My A is negative. It's not going to give me, it'll give me the integral, but it won't give me the area. So if I want area, I could come in and say, well, if I make A negative, and it's already negative, it's going to make it positive, right? Which is the same thing as B minus A. So if you subtract the negative areas, it'll make all your areas positive. Yes. Right. Right. Displacement is final minus initial. Displacement is final. Shut up.
I'm probably gonna miss this part.
$399.11. Recall that, and this one does give you there's your equation, 32 feet per second squared. That's your acceleration. It does though. It says recall that the acceleration due to Earth's gravity is 32 feet per second. There's no variable in there. It's just acceleration is always 32 feet per second. And if you're falling, it's negative. So if I go backwards and I integrate, velocity is going to be the integral of negative 32 dt, because I'm doing it with respect to t, which is going to be negative 32t plus c. And it says fire straight upward with velocity of 90 feet. It's got a velocity. No, well, you have to plug it in and see because it says your initial velocity is 90 feet per second. So at time 0, if that's initial means when it starts. So when time is 0, velocity is 90. So 90 equals negative 32 times 0 plus c. No, you don't have to. It's given to you. Yeah, no. So my velocity equation then is negative 32t plus 90. Now you do position, that's right. And so now I go backwards again, and so I integrate. You've got to have a plus c for all of them because they're not definite.
I didn't use it.
Well, this one, the c comes out to be 0 on this one because you start at 0. You start at ground time 0. At time 0, your position is 0 because you're on the ground. So 0, 0. So if you do 0, 0, c is 0. So this is your position function. What else on your homework? Isaac Newton and Lebeinz. Somebody said they had another question.
Last night's homework, 37.
What do you want me to do with it? What's the velocity after 3 seconds? So plug in 3 in velocity. When does it hit the ground? So when is position equal to 0? When it hits the ground, what's the net distance it's traveled? So that's final position minus initial position, which is 0 because it ends up the same place it started. When it hits the ground, what's the total distance? That's where you do the absolute value. So it traveled, what's your total time there? When it hits the ground, what's the total distance it's traveled? So what do you do? Total distance. So I'm going. So when does it hit the ground? What is your t? You have to use your answer from part B. So so it's from 0 to 5.625 of whatever that velocity equation. We got it in part B. When does it hit the ground? We set the position equal to 0 and solved. Do what? Do this. So I'm going to take, so that is the position equation, which is negative 32 over 2 t squared plus 90t evaluated from 0 to 5.625. I'm going to plug in 5.625 first, and actually that's all I have to do. This is 16. Distance traveled. Distance traveled is always the integral of velocity, but it's absolute value. Position. It's position measured on a distance, like on an interval. Yes. The integral of velocity is position, is total distance traveled, excuse me, total distance traveled. Area under the curve. What?
I could already like
37? You sure you want to do it later? It might look very similar to one on the quiz.
Yes, do it.
Find the area of the propeller-shaped region enclosed by the curve x minus y cubed equals 0, and I lost my place, x minus y equals 0. So I need to solve for one variable and decide which one I'm taking with respect to. Do with respect to y. Are you going to be able to graph that with respect to y? Let's do it with respect to x. I agree. So let's say y equals the cubed root of negative x. Would you agree with that? That's with respect to x. Yes, you do. You should. That's one of those parent functions. You can. This is a calculator problem. Well, if you move the x. Oh, you're right. You're right. It's positive x. Okay, sorry. And negative x. All right, let's graph this and see what it looks like. God almighty. Okay, sorry. Yeah. I'm trying to rush and I'm getting, okay. I'm going to graph the cubed root first. 0, 0, 1, 1, 2 would be up at 8, right? I mean, nope. 8 would be up to 2. So we'll just kind of go like this. This is the top part of the cubed root. The bottom part, of course, comes down and does the same thing. I don't think I'm going to have to worry. Maybe I will. No. I'm not going to have to worry about that portion of it because I'm talking about the line y equals x. All right, so this one is kind of curving like this. This y equals x is doing this. So I'm talking about, and this might be a really good one to graph on your calculator because the hardest part to this, in my opinion, is determining which function is on top. Is it the cubed root? It looks like it how I graphed it, but don't trust my graph. I'm thinking the other one. Let's graph. Correct. Is it? Ooh, I can't zoom in enough. Okay. So, but I got to have intersection points. I know this is x equals 0, but I need to know what this value is. Again, if I have my calculator, that's easy peasy, right? Well, for this one, let's see let's read it. The area of the propeller-shaped region. I'm gonna say that they're only wanting one of these, but they could be wanting the other one. We may have to double it to get the other. If they want the other, yeah, right. Mm-hmm. All right, so what's that intersection point? What's my x here? Did you calculate it? 1? Or you could do cubed root of x equals x. Yes. If this was a calculator problem, I definitely would. So I would go from 0 to 1 of the top curve, which is cubed root of x minus x dx. This should be an easy peasy integration for you. The antiderivative of x to the 1/3 is the 0 is nice because I really don't have to worry about the 0. Well, they're saying because if we extend this out, there's 2 propeller shape there, so we double it to get that second. I'm gonna say since if you propeller shape, they probably want both ends of the propeller, right, Dylan? On a plane, 2 parts of a propeller. If it says propeller, yes.
So it sounds like we're having this exact same question. I'm gonna get it right.
So this is a fourth. So doubled. It's not negative.
It has to be positive. How many was see? That's that was good. Let's start totally the exact question. Wait, so what about the y stuff?
What about it?
Like, can you do one that's
So if this was with respect to y instead of, let's just take this exact same one. So I would solve this equation for x instead of y. So it'd be x equals y cubed. So this, it still graphs the same, right? So this is y cubed. This one would be y, right? So this time I'm going to do, but I have to take, for this one I have to take the y value. So from 0 to this point was 1 what? Is it 1, 1? Yeah, it has to be. So I'm going from 0 to 1 on the y part. But this time I'm doing the right, so it's y, minus the left, y cubed, dy. And then it's the same way. So it's a little bit easier with respect to y on this one. But this would be 1/2 y squared minus 1/4 y to the 4th. Evaluate from 0 to 1, you get the same thing.
so with respect to y, it's not much different.
It's not, and that's what Dylan was saying. You can actually do them all either way, whichever way is easiest.
The only one that I was confused with was if it's like they don't connect, like they don't intersect. Like, is it gonna give you this, like, you know what I'm saying? Like if they don't, I think that's what Dylan was talking about earlier.
They'll give you the bounds.
Okay.
So like if it's something like, I think what you're talking about, I think this is what Dylan was talking about.
Yeah.
From here to here,
You have to do it with respect to.
they would have to give you the bounds there if you do it with respect to y. You can't do it really with respect to x on this one. I mean, you could, but it'd be infinite
You
area.
have to do it with respect to y.
Right.
Let's say it's 1 like 1 4 with respect to y. Find the bounds.
It's still the intersection points.
Yeah,
But it's the y value of the
It's the
intersection.
farthest to the right that's on top.
Well, that's. Oh, yeah, I feel like my head just information overload right now.
Well, let's get this quiz done.
Yeah, let's get it done. I don't even know if we have time.
Y'all are fixing to be really mad at me.
Yeah. What?
We're
That's what you want.
gonna do it in the morning first thing when everybody's here. And we're gonna talk about volume for just a minute. So take a 5-minute brain break. You try to take the limit and you get 0 over 0 or infinity over infinity. You take the derivative of the top and the derivative of the bottom, and then you try to do the limit. That's not true, Dylan. No. Can't divide by 0 because that's undefined. No. We'll talk about. Okay. I should have brought in a loaf of bread for this to demonstrate this because I feel like that's what makes this the easiest to understand. So for volume, when you find volume, it's generally we're going to use integrals to find volume. And so we're going to do some shapes that you could theoretically find the volume of without integrals, but then we're going to get into some shapes that you have to have integrals. No. But we are going to start taking like those little, it's going to be so cool. That little propeller piece, we're going to rotate it about the x-axis to make like a washer shape. And we're going to find the volume of that washer shape as it rotates around. Yeah, but we're not doing rotation today. Today, basic volume. Basic volume. Okay.
So this is not going to be on the quiz.
No, this is not going to be on the quiz. All right. I want you to think about a loaf of bread. And if I needed to find the volume of that loaf of bread, do you agree that I could take a slice of that bread? Are you picturing yourself taking a slice of that bread? And find the area of the slice, multiply it by its width. Exactly. Right? Right? We all agree. That is the thought. That is the right.
So only if there's
It is. We've done this. We've essentially done this. Really, is what we've done. So, but that's what I want you to. I want you to be able to visualize the cross section when we start talking about cross sections. Okay. So here's what we're going to do to find the volume of a solid. And the first example we're going to do is a pyramid. I need to cut mine. Notebook paper or computer paper? No. I do have computer paper.
Now, next question. I really came unprepared today.
Oh dear Lord.
I left my pencil on my desk.
There should be one on my desk.
I only have like one pencil.
I know y'all hate to sketch, but sketching is going to help you with these. It will help you visualize to see what it is you need to do. All right, so we're going to sketch. We're going to find an area formula. Now, for today, we'll be doing things like using square cross sections or using triangular cross sections or using circular cross sections. Well, you know how to find the area of a square, a triangle, or a circle, yes? Okay. Yeah. No? Area of a square, length times width, triangle, half, base times height, and circle, pi r squared, right? Basic, basic. And then we're going to multiply it by the width. But the width we're going to let be, do you remember what we let it be whenever we were doing the integrals before? But in an integral, what represents the width, do you remember? The dx. The dx in the integral is what represents the width. Now, okay, okay. Well, it does mean with respect to x, but it represents our width. Okay, because whenever we integrate the yes, you're going to find the area formula. You're going to find your limits as far as what we're going from, which is generally going to be 0 to whatever if I'm talking about a shape. And then I am just going to integrate to find, well, yes, because volume's always positive. This is the hardest part on this one right now. So, for example, this is really easy today. A pyramid, and I'm just reading this straight from your book. A pyramid 3 meters high has congruent triangular sides and a square base that is 3 meters on each side. All right, so let's try to draw this as best we can. I've got this pyramid. Oh. Nope. I am not artistic. And y'all know this. Okay. That's pretty good. I'm a little impressed with myself. Okay. Here's my pyramid, 3 meters high. So from top to bottom, 3 meters. Yes, the height is 3. Square base that is 3 meters on each side. So square meaning, let's draw 3, right? Find each cross section. Now, whenever it says cross section, think about that piece of bread being lifted out of the middle of the loaf of bread, okay? So the cross sections, each cross section of the pyramid parallel to the base. So my cross sections are coming out like this. Parallel to the base. Right, right. So we need to lay it on its side, kind of like a loaf of bread is laying on its side, so we can see it a little better, right? They're not all the same, but we're going to take that into account because this looks a lot like if you laid this on its side. Right now I'm kind of with respect to Y. So if I lay it on its side with the way the cross sections, I'm definitely not going to be able to do it on the side. Yes, Lizzie. Thank you. Okay. Okay, well that one's not gonna look, that's not gonna be performed. Okay, but there's my piece that I'm sliding out, right? This looks like, as I continue to take these pieces, this looks a lot like what? Something you've done before. The what? The RAM stuff. It looks a lot like the RAM, right? Remember when we did the RAM? So what integration does, remember, it all ties, this is where we come full circle now. It all comes back to limits and approaching infinity, because what integrals do, if we could get an infinite number of rectangles or squares in here, that would give us the area or the volume, right? And so what integration does is it gives us that infinite number of, you don't have to understand. Yeah. It is cool, but that's what it does. If you look, if you go back when we first did integration and we did it with the summation notation, we did it as it approached infinity because it's an infinite number of rectangles in here. Okay? Huh? What? You aren't the only one. Well, they'll be infinitely small. It's more conceptual. Yeah.
You know what I'm saying?
It is, right, right. Okay, so I asked you, let me read the question again now that we've got it set up and we see what everything looks like. A pyramid 3 meters high, and you need to kind of envision this on a coordinate plane if it helps you. 3 meters high with triangular sides and a square base is 3 meters on each side. Each cross section of the pyramid parallel to the base is a square. Find the volume of the pyramid. Okay, so the first thing, no, it's going to be exact. And we'll actually look up volume, the equation for the volume of the pyramid and see how. No, you have to use integration. All right, so look, your first step, we sketched it. Find a formula for the area. That's going to be my first job. The area of one cross section. So it's a square, right? So what's the area going to be then? But you said it varies, right? It's not the same anytime. So let's put a variable in for it.
What if you just found the area of one triangle and then multiply it by the length of the square?
Do you agree that the area of a square is x squared here? Okay. Find the limits of integration. What am I going from? 0 to 3. How do you know? That's how far across. I start at 0. This whole distance here is 3. So I'm going to do from 0 to 3, x squared, which is the area of one piece, dx. Right. Now, evaluate it. 1/3 x cubed, evaluated from 0 to 3, which is 1/3 times 3 cubed minus 0, of course. And this isn't exact because I'm using the square that are the same. That's correct, sorry, yes. Meters cubed. Somebody look up how you find the volume of a pyramid. What's the length of the pyramid? 3, 3, 3, right? 3 times 3 times 3 over 3. Shocker, it's the same thing. Isn't that cool though? We just used an integral to find.
So we didn't even need to use the integral. We could have just used the volume.
That's what she said. She said the.
I'm showing you a basic example so you see how to do it, but everything's not going to be that easy, and let me show you why.
But if you gave us one like that on a quiz or something, I don't even have to do that. I don't have to.
So we might not know.
Oh dear Lord.
But what if you don't know will you always know what the length is, the height and everything? You know what I'm saying?
Not always.
If it's not,
Well,
you don't know
right,
what's
right.
If it's not given to you, if you have the volume, then it's given. If like one variable isn't given to you, and you know the volume, then you'd be able to find the other variable.
Right.
But would you be able to use any variables to do that?
He said. No, good. Yeah, we won't be doing any of that. I'm trying to see. Let's work through a couple of number ones. This one, yeah. In numbers 1 and 2, find a formula for the area of the cross sections of the solid that are perpendicular to the x-axis. Okay. So we're not finding the volume right now. Right now we're just trying to find the area equations, okay? Now, number 1 says the solid lies between planes perpendicular to the x-axis and x equals -1 and x equals 1. The hardest part about this too, besides the area, is trying to visualize this three-dimensionally. It makes it a little hard. They do on these. The cross sections perpendicular to the x-axis between these planes run from the semicircle y equals negative the square root of 1 minus x squared, and the semicircle y equals the square root of 1 minus x squared. So this is a solid. That's exactly right. This is a whole circle from -1 to 1. What? All right, this is a solid, okay? So it does not look like a solid, but it's a solid, no. The first thing it asks, and we're using this same one for A through D, okay? So the first thing, A through D on number 1, yeah. The cross sections are circular discs with diameters in the XY plane. So how do I find, and so we need to think about what this means. So cross circular, so from here to here, I've got this circle coming out of it. I need to know how to find the area of that circle. This is square root of 1 minus x squared. This is negative square root 1 minus x. Well, I don't know. Tell me, how would I find the area of the circle? How do you find area anyway of a circle? Pi r squared. So what I need to figure out is the radius of this circle, and it's centered. What?
Wait, yeah, but it would make the parabola positive. I just said that.
Okay. What? My question here is, what is the radius of this circle?
Are we good with that?
No, it's 1.
Y'all. Not the radius. Not the radius of the big pink circle, the radius of my green circle, my green cross section. It does, so give it to me in variable form. What's the radius? Radius is half, do we all agree? From here to here, how far is that?
Dx.
I just told y'all 1/2 green line. It's
It's the y value. It's the y value of the function. What's the y value of the function? No matter where you go on this circle, y'all, that point is, that's how you find that point. The square root of... No! No, Dylan, no. It's not divided by 2 because from the x-axis up to here is the square root of 1 minus x squared. The diameter is 2 times the square root of 1 minus x squared. Okay, so the area in terms of x of the cross section, one single cross section would be pi r squared. But they cancel, so the... Oh.
Wait, what the heck? Wait, what's the radius again? I thought you said the radius was a half. Yeah, why is it not half?
Half of the diameter, sure, but where are y'all getting a half from?
A half.
You're listening to Dylan. Don't listen to Dylan. Look, this distance is always, no matter where I am on my circle, that length is the square root of 1 minus x squared. Does that make sense? No, we're not even, this is just setting up. It literally says, find a formula for the area. This is getting us set up to do volume. Oh, yeah, I'm sorry. Yes, sorry. I got all excited. No, won't you stop right there? That's it. Yeah. Okay, yeah, that's it. Yeah. That's it. It said find a formula for a of x of the cross sections perpendicular to the x-axis.
It's a serious question.
Okay. If I had a ball and I cut a piece out of the middle of it, right, like a piece of bread sliding out of the middle, right? That's what this green circle is. So we were just finding the radius of the circle because that's what we need to do. Let's change this. Let's say part B says the cross sections, that was A. Same setup for all of these. The difference is the shape that I'm using to pull out of my circle. The cross sections are circular discs. The question is the same for everything in numbers 1 and 2. Okay. Now the cross sections are squares with their base in the xy plane. So squares is the key word. So this is a square. How do you find the area of a square? No, that it's not. That's the base of it. It's coming out 3-dimensionally. So whatever this is also going to be the height that it comes out also. So, okay. Say that again. Area of a square is, we said it's side squared, right? We agree with that. The side in this case is all the way across. Do you agree? So from here to here. Well, if half of that distance was the square root of 1 minus x squared, there's 2 of those there, right? So the side of my square is 2 times the square root of 1 minus x squared.
The area is that square.
Yes.
Yes. Why is it that? Why is it?
Because there's 2 of them, right? This, if I just did square root of 1 minus x, it would just be from here. But I need the whole length of the square. It would be side squared.
Yeah, so it'd be
4 times 1 minus x squared.
Okay, yeah.
4 minus 4x squared. Either one. Or distributed. You don't have to.
So, this is, please, like, the negative square root of 1 minus x squared on the bottom. Wouldn't that be the radius also?
Okay, that is the radius, but your radius is never going to be negative because it's the same as distance. You're not going to calculate the area of a circle and have a negative radius. That doesn't make sense. You're going to do the absolute value of it, which is positive, which is the same thing that it is up top. Really, this is the equation of this circle is x squared plus y squared equals 1, if we talk about it in terms of a circle. But does it? Sorry.
So why, okay, we have two things. Why do we?
We did that so that we would know the distance from the x-axis up to here, because we needed that whenever I was doing circular cross sections, I needed the radius. But now I'm not doing circular, now I'm doing square. So a square, square has all 4 same sides, so if I find one side length, which is here, it'll give me that total. I can find the area of all 4, with all 4. Is this not making sense to y'all? Is it hard to visualize? And if you look at the picture in your book, I know a lot of you don't have your book with you, but let me show you because it's a little easier to picture, and maybe that'll help you. All right, look at this one. There's my circle, and you see the 3-dimensional squares that I'm cutting out of it. That doesn't help you at all, does it? All right, part C. I know I got 2 more to go. The cross sections are squares with diagonals in the XY plane. Okay, so that means that this length, okay, that length that we have already found is the diagonal of a square. So this right here is 2 times the square root of 1 minus x squared. So it's basically 2 triangles. So how do I find, it is a 45, 45, 90 triangle. How am I going to find one leg of that triangle then? Because right? So 45, 45, 90 triangle. If this is x, this is x times the square root of 2. But to go backwards, go from here to a leg, what do? If you multiply to get to the hypotenuse, you would divide, right? So this is 2 times the square root of 1 minus x squared divided by the square root of 2. Y'all, and think about it. This is not even, we're not even integrating. We're still, this is like geometry.
What is with, how do you know that the line is 2? Oh, wait, this is the side.
Right. Well, it says the cross sections are squares whose diagonals, and it even told you in parentheses, I didn't see that, the length of a square's diagonal is the square root of 2 times the length of its side. I love this kind of stuff. At what?
The diagonal is
the diagonal is what's sitting right here.
the side. Right? Because 2 square root. That's the side. Is it not?
No.
Side equals 2 square root of 1 minus x squared. So it has to be the side.
The side of a square who sits. Okay, if the square, look at the difference. Look at the difference. if the side sits here, but the side doesn't sit there, the diagonal is sitting there. So to find the area of this square now, because it's twisted, I'm going to have to do this squared. How do you find the area of a square? Side squared.
What did you plug in? Like, why is 2 square root of 1 minus x squared in the middle?
That's the diagonal of the square.
Okay, so the diagonal is the same as the hypotenuse this would be?
Yes.
The answer is 2 times 1
If
minus
this
x
is my square,
So then,
if this is my square, what it's saying is this diagonal is sitting in between. That circle is cutting this right in the middle. So this is my square. So this length is the length of the radius we were using before, or the diameter.
just like this square, like
Yes. So whenever it was sitting like this, then the equation itself was giving me the length. But now it's twisted, so my square is different now. Not necessarily cut in half, but the square's been twisted. So if I had some type of circle, instead of it sitting like this, and this equation gave me the side, when I twist it like that, that equation gives me the diagonal now instead of the side. Do you see what I'm saying? So this is like that thing is cutting it, slicing it in the middle. This sits. So how do you find the area of that square? If you know the diagonal of the square, how do you find the side length? Because the area of this square is side squared. So how do I get, if I've got the middle, how do I find the side is the question.
square root of 1 minus x squared over square root 2. That's the side. Is it not?
Oh, yeah, but watch this.
And then you square it to get both.
And then you square it to get both. So the area is going to be, if I square this, I get 4 times 1 minus x squared over 2, which is 2 times 1 minus x squared.
Okay, I've said that.
Y'all gonna be late. If the cross sections are equilateral triangles, is that what he says? If these are equilateral triangles, this is D. Okay. This bottom is now what sits here. We've already found that length, right? Look at it. The bottom of the triangle is what sits in the, right, the base. So the base, tomorrow as soon as you walk in, you're doing your quiz. The base of the triangle is what we found. That's the 2 times the square root of 1 minus x squared. That's the base.
Yes.
Now, how do you find the area? If this is, they are, but how do you find the area of a triangle? You've got a base, you don't have a height. This is what I need.
So how do we find the height?
3069 triangle.
Which one? Wait,
This is 60, this is 30.
Oh, you want us to split it? Oh, okay.
Now y'all find it. Go to class, go to biology.
The height is x.